topic that all of us know already, so I hope that you guys can participate as well and make this more discussions. So we're going to talk about code refactoring today. So what is code refactoring? Well, what is code refactoring?
So right now, refactoring is change the code but keep the same result.
Okay, keep the same functionality of the piece of code. What is the purpose of changing the code?
Usually for cohesion. So make the code clearer for other to read.
Correct. Alright, yeah, that's pretty good. So refactoring is the act of changing the code, modifying the code, so that it makes the code easier to read, easier to understand, and make changes in the futures. Please notice that not all code modifying are refactoring. In contrast to code refactoring can be performance optimizations, where you aim to make the code run faster. And to acquire that, usually you put in complicated mechanisms such as caching or nested looping to reduce the calculations the computer needs to do. So it depends on the purpose. It can be either refactoring, it can be performance optimizations, and it can be something else. In the context of the talk today, we are going to talk about code refactoring alone. So usually, when do you guys start doing refactoring? We covered a lot.
After we finish that functionality.
Now, when usually you do code refactoring, let's start with a more detailed questions. You have a big phase of refactoring. Are you refactoring? You divide the refactoring into small pieces of work. What is your favorite? Small piece, done. Any big thing, big phase of refactoring?
There are times when big refactoring are needed.
So
like if you plan to implement a new feature, but the new feature would require a lot of messing if the structure of the code is not changed. Then it would be easier to refactor the code first to make it more modular, or to make it work with plugins, or to make it work with different things before you make the new changes.
Yeah, right. That's very good. Depending on the context, there are different times that we need to do refactoring. But in overall, as a whole, I believe that refactoring is better to be done in small pieces of work rather than writing bad code and stacking up things into a huge amount of work and then do it later on. It's not just harder because you somehow forget the code already. It's also frustrating for your coworker. So as for mentioned earlier, one of the good time that we start refactoring is when we add a new functions, new features into the code. And very likely these features, these functions will involve all the existing code of the system. So probably that's a good chance for us to look back, things that related to that specific functions and make changes. Another good time would be file. So when we file up, the first thing we ever do in our refactoring was to fix that bug first. But then it can allow that we better think, how did that code happen? If it's just a logic bug, then probably no need for refactoring. But probably that you have two functions with same signatures but different list of parameters, and therefore your coworker didn't know that they end up using the wrong functions. Things like that. Whenever you find a bug, think of the way how did that bug happen. Can code refactoring help prevent that situations in the future? And another time would be when you do code review with your friends. So last week in the retrospective meeting, we said that please try to do code review. Who here has been doing code review this week? Great. How about this side?
I've been doing it forever.
Alright, good. So good time to do code review this because what? When you do code review, very clearly you are not looking at your code, at your friends, and you bring freshmen into it. You bring use of XD into the code, and probably you figure out things that wrong with the code that the writer didn't recognize earlier, and you suggest to your friends how to change it. Although the title of today's talk is Code Refactoring Technique, I'm not going to cover the technique today. The next thing I'm going to cover is how to detect code that needs refactoring. And perhaps next week or the next 2 weeks we can figure out the technique in detail. Sorry. Is there anything that you guys want to add in when to refactor the code? Alright. So that brings us to the biggest questions today. What should be refactored? So, hope you have been doing code review for like forever. So, whenever you look into a piece of code that you do code review, how do you know that that piece needs to be refactored?
Well, there are many different signs, but the common signs are sometimes you would see that there's a hard-coded string in the code, and it's not always, but it's likely that if there's a hard-coded string in the code, that hard-coded string will have to be somewhere else. For example, you are checking for a variable, for an argument from an API request, and you are checking whether, say, the version is 1.3, and it's likely that 1.3 is in the code, and it's likely that you need to use it somewhere else, and it means that this code has some problem. It might be better to put that thing into a helper function, or maybe put that into some kind of constant, or do it some way so that you don't need the hard-coded thing.
Okay, good. Great. So, mobile guys, when would you find that it's necessary to refactor this code? Based on what factor you determine that code is bad?
For me, usually it's like when you look at the piece of code and you find out that there should be a better way to do it.
But it means that you need to look through every line and figure out.
When you do code review, so when you do code review and you find, so this guy fixed the problem in this way, and you think that there should be a better way.
Okay, so bad logic.
Yeah, sometimes bad logic, sometimes bad use of the framework.
Okay, sorry, I don't know how to write it down. Alright, Long.
For me, I just think that sometimes there are repetitions in the code.
Duplicated code. Duplicated code. Why duplicated code is so bad?
Because we might need to change a little bit in the logic, which was duplicated, but it was duplicated multiple times, and we need to change everything.
Yeah, that pretty good factors of bad code. Another thing that I usually rely on is the size of the method. When the method is too long, I believe that it's small. It would be better if I can break it into smaller pieces.
Actually, there's another metric that complements the length of the code. There's something that runs there's something that look at the code and assess the complexity of the code. So if you, so for example, if you have a loop, then it adds some complexity, and if you have another loop inside that loop, it's worse than having a long method. And say if you have if, else, and loop together, it adds to the complexity. So there's some libraries that analyze the code and rank the complexity of functions. If you want metrics, that might be a more scientific way.
Yeah, but the downside that they actually need to run through.
Yeah, it's hard to see in real time.
In this thing, this metric is like you look into a class and you somehow automatically narrow down the area of things that you need to refactor. Probably you look at a long method and then you think that it's more worth looking into detail rather than a short getter or setter. Then start to dig down into level of details and see if it can be refactored or not. The problem of long methods in general is that it's hard to read. Sometimes like basically a method should do one thing only. And if you read through half of the code and you cannot figure out the purpose of the method any longer, then probably something should be refactored into a set of methods.
Yeah, but I have also seen cases where there's a long method which is very simple. Things just go one by one. And then when breaking one simple method into say 3 different methods and make them code together.
Yeah, right. None of these metrics we listing over here should be used as its absolute meaning. It's just hint for you to detect error that is refactored. Long method of duplicated code doesn't mean that it must be refactored. Sometimes duplicated code is necessary to keep the solution simple enough, and especially in case the time is a bit constrained. But anyway, let's keep listing more metrics. Long methods lead me to the next matrix, which is big class. Similar to method, class is best if you do a few things and do it well, rather than try to accomplish way too many things. Okay. Anyone else has? Yeah.
Actually, well, in web it's less of a problem, but in mobile there are classes that are kind of huge. I've seen it in iOS, I've seen it in Android, and I don't really see a way to make them smaller. Right? Do you have huge classes in iOS anymore? I remember I saw some classes that goes like 200 lines, or maybe 3, or maybe 5.
No, 200 lines is normal.
Big
class is not the length of the class, but how many things the class trying to do. For example, like we have an account view, an account object, and we have to handle, we need Facebook account, Twitter account. The best way is to subclass that class into another different, not just in one big account class. And we just, if it's Facebook, then we do this, if it's Twitter, we do that. That is the big class. We just split it and into Facebook account, Twitter account. I think so.
Yeah. It's just similar to long method. Long method doesn't necessarily mean bad, as long as people can make sense of that. Big class doesn't mean it consume more line code, but it tries to accomplish way too many things, and it's hard to read through one kind of close code, because like in example, when you read through the method of that account class, you need to keep in mind this is for Facebook, this is for Twitter, this is in mind for some other social network. Okay, anything else? Anyone want to add some automatic?
If statements.
If and switch.
Maybe, but sometimes switches are not bad. Yeah, but in Python you don't have to switch it.
Yeah, they claim it because it's just equally bad to switch multiple if statement. So what's wrong with multiple if statement?
It's just that most of the time there's something better you can do about it.
Oh, that's similar to what we mentioned earlier, right? There are better ways to do the same thing. Most of the time, how do you solve the problem of having way too many if or switch statements?
Usually, so when you have too many if and one method, that means that method tries to do too many things, or it try to cover too many cases.
Okay, so the first way is to break it, right? Into smaller chunk. Okay. How else? Polymorphism.
Could be.
Like,
Yeah, instead of making if, you're making subclasses.
yeah, you make subclasses and it designs whether the code will be executed on its own or for the switch statement. Because I work mostly in Python and Python doesn't provide these features. What I usually do is combinations. Oh, no polymorphism at all for Python because in Python just need to have that exact method signatures. You don't need to declare it, and therefore there is no need for a common interface. Usually I use that together with a dictionary. Dictionary keep a bunch of value, and then different class that capable of handling that to replace the switch statement. Okay. How about long parameters? Long parameter list. Can I erase this one?
Yeah, go ahead.
How about this? Have you ever you call a method that takes up to like say 6-7 parameters?
When drawing.
Mean what?
And usually it's when you call a draw method.
Draw.
Yeah.
Right. In Java Swing.
Yeah.
Any other example?
Seen it lately.
Haven't seen it like
Well, most of the time when the parameter is complicated, they use options parameter, and you put things in the option and you just pass the option.
Oh, you mean use dictionary to get around?
Yeah, I've seen people passing options, but lately I haven't seen people passing a bunch of parameters.
Yeah, or they can as well pass an object. But that brings to another problem that I will mention later.
Sometimes it's just the constructor is too long.
Oh, if it's the problem of the constructor, then there are plenty of design patterns to get around, like
We can just
builder.
builder.
Okay, but long parameters is prone to error. Like it's a list of 6 parameters, and you put 2 of them in the wrong order, especially dynamic language like PHP or Python. There is no compiler telling you that you are passing the wrong data type, and you will not detect it until it's basically grasped. Or even worse, if those two are 2 objects, then somehow it will keep running for a while until there's some functions call happen to it. Because in both Python and PHP, you can just freely add more attributes to an object without any error. Won't change. Another thing that I really hate especially when I add new features is multiple small change. Usually I find two forms of these multiple small changes. It can be multiple small changes that happened within one class. Like if I want to add one more features, or if I want to swap one more database, I will need to change the 4 functions. If I want to add one more customer to the order, I need to change the 5 functions. But as least it's good, it's still in one class, and somehow the functions are related to each other. There is another form that even worse, is that I need to make a series of small changes in a lot of different places, different classes. Usually that requires a fair amount of refactoring. You need to find out what is the common thing that those classes sharing, and then you extract methods or you extract class out of that. We will go into the detail of the technique, how can we handle the problem later on, perhaps next week. Let's move to the next point, is the heavy use of primary data type.
MA.
MA.
Why not ambient?
Primary.
Primitive battle.
Primitive. Yeah.
You set me in the wrong direction.
You say primary.
Sorry. Heavy use of primitive data. So most of the language come out with a set of primitive data sets, like, can you name it? Integer, or double, string. That is two forms in different languages.
How do you define primitive?
Or not a class.
String is sometimes a class.
In Java, yes. Not a class.
In Python, pretty much everything can make functions. In Ruby too.
Yeah.
So it's hard to say what is primitive.
Well, the one with built-in support from the language. Like you just don't need to define.
So like built-in data types.
Okay, but if we say built-in data type, we can get to the collection thing.
Okay.
Okay, so this kind of blur definitions, but you can't get it right. Characters, strings, numbers. For beginners, developers, they usually agree to write a small class to do a specific piece of thing. Instead of that, they usually try to bundle some primitive data together and add functions on top of that. A usual example that I usually use when I do interviews, I ask people to implement features that related to money. And to implement money, they usually just add an integer for value. Then later on, if I ask them to convert the currency from one to another, they will ask another thing if you want to convert money, you need to base on the interest rate right at that moment, because the interest rate of today might be different from the interest rate of tomorrow. And at this point, this no longer works. You need to refactor it, put it into a class called money. Then you start to add functions into it, like convert. If you keep sticking to in values and then a string representing currency, then you will end up in spaghetti code that try to do way too many things. Okay. Earlier we said that one of the ways to get rid of the long parameter list is the options, which is basically a dictionary. Another way you have a data object. So, how do you decide when to use which? Nguyen?
Normally, I use the option much because I can merge all the parameter and use it easy than that object like this. If you use that object, I need to access the attributes. Then.
But for language like PHP or Python, you just add more attributes to it. You don't need to do anything else. So if you count the line of code, then more or less the same to dictionary. Okay, Tường Lê, what do you think?
I use option is if the parameter should contain the raw data.
Raw data. And you use data object when would you use the second option, data object?
It depends on what language you use.
Say, which one are your favorite?
I'm working with JavaScript now.
Well, JavaScript is a bit weird. It's the same for both.
Yes.
So, say PHP for example.
PHP?
Yeah.
So normally I use options.
Alright. A rule of thumb of mine to select when would I use option and when would I use data object is that I would use options when the list of parameters has the meaning purely about data only. And I would use data object if I will eventually doing something with that bunch of parameters.
Which order attribute of that object?
Not necessary. I can break it into groups that related to each other. I don't.
One example.
Huh?
When I try to transfer the data from the controller to the view, normally if I need, sometimes I need to access some attribute of the object, I did is just transfer the object to the view. If something not need to, I try to delete that in future. I don't want to get something else, so I just transfer the parameter and option.
Alright. Yeah. What I'm trying to say is, I will choose that object when I need to have functions to operate on top of those parameters. I want to avoid the case where I create a class with just a few attributes and a bunch of getter and setter. Basically, it's purely a data holder. It doesn't do anything to the data that it holds, other than except giving away and changing setting value. If that is the case, then I would like to just use options, which basically the same. I don't even need to write getter and setter. Data object is only valuable when you intend to perform some sort of functionality on top of that data. Okay. The next two things are kind of related to how you design your applications. First thing is meshing, chaining. Okay. When this happens is when you see an object calling one object for an attribute of that object, and then keep going on like that. You know what I mean? Like I have an object. I call the get this, get A, can get B, can get C. In order to set B into E value. The message changes, and this means that I might be breaking my diagram into two small pieces, or the way that I'm constructing a class is wrong, and therefore the responsibility is spread among classes. Another thing that's related to this, related to the same error, is feature entry. How do I know this? I noticed this problem when my class seems to be more interested in the functions or the attribute of another class. Like most of the time what they do is it keep a reference of another class and operates mostly on that. Let me give you a small value or example. Okay, so we go to class A, we keep a reference of class B, class B, and for most of its function, it just delegated to B. So it even probably it can be it's a separate class on its own. Most of the time, more than half of its, for example, more than half of its function is just delegations. It's nothing more than just a middleman. There are many cases that a middleman is important. For example, like in some design patterns, so that adapter, process, file case. But other than that, if you know that what is the delegations is doing, what the specific purpose is serving, then probably you are okay. But if it's just the result of some refactoring and now you are doing a bunch of delegations, then probably that is one more class that you need to do refactoring. Okay, let's go through quite a lot. 10 metrics, how you measure a class or a method that needs refactoring. Is there anything else you guys want to add to it?
You read the code and you don't understand.
Read it again, maybe how you
No,
do refactor it
it's
without
not
understanding.
because I don't understand. Most of the time it's
Readability.
because, yeah, the readability of the code.
Readability. Oh, yeah, but there might be two factors, other two reasons to that. The first might be it's just bad code and probably it needs to be rewrite or refactored. I don't know. I think that if the code is bad on its own, then it needs to be rewrite, not refactoring. Refactoring most of the time is to move things around rather than reconstructing, rewriting it. Another reason would be is trying to attempt to do actually complicated things. Like think about a streaming video or a streaming player receiving packet from a streaming server. You need to concat them together. And that's simply a complicated piece of work which we cannot solve it with simple code, right? Or it can be doing performance optimizations, as I mentioned at the beginning of this talk. So usually code that optimizes for performance will be complicated. It do some weird thing to gain performance. Okay. Someone said that when you have a lot of commands in your class, it means that you need to refactor. What do you think?
Makes sense. Doesn't make any sense.
Comment, you mean the comment code or
Comment on the code to explain explicitly what the code is doing. That's what you say. Lots of comments on the code. Yeah. If the thing is complex, I think it's okay. But the thing is simple, we actually a lot of comments. I think we need to remove our comments. Okay. From the part that I read, the author reasoned that because when you need to use a lot of commands to explain for your code, then the code itself is not clear. The code itself is not self-understanding. And therefore, probably it's one of the errors that would take a look into whether or not refactoring is necessary.
Oh no, that person sounds like Brennan.
Yeah, if you read it, then brand and philosophy are more or less the same. Code should be self-explaining. Usually, his only command is to do or fixing.
the readability of the code will not be judged by the one who write it, but another one. So it's better like you write the code, you write the command, and someone review that code and see if that command is unnecessary, then that guy will remove the command, not you. It's better that you write the code and you see it's readable, I understand it, and you remove every command.
Okay. Has Bart ever been used for removing his code?
I remove that code.
Yeah, you read that code and you see this is garbage. Okay. Alright, that's the end of my talk. Is there any other questions? No. Okay, thank you. This is the feedback from Nguyen. He didn't know what he's supposed to do.